All right, so we've just shown how we can determine the limit in number 18, even though they didn't ask us to. Oh, actually it does say find the limit if it exists. Didn't read that part. Got to read all the directions, you know. All right, fortunately I did that for 18, so you can do it for 15 and 17. All right, now in 19 through 28, so we're going to look at 20 and 22 because they're both rational expressions, right? So I have a polynomial in the numerator, polynomial in the denominator. That's called a rational expression. In this expression, the numerator is rational, is a composition, a difference of rational functions, and the denominator is a rational function. So this is called a compound rational expression. Some people call them complex rational expressions. I think that's misleading because it's not complex numbers. So a compound rational expression is a rational expression where either the numerator or denominator or both are themselves rational expressions. Blah. All right, so a bunch of fractions with x's and t's in it is what we're talking about. Notice that 24 through 28 all have sign in it, so we're going to need a completely different technique. But for these, number 18, 20, 22, or for, you doing your homework, number 19, 21, 23, those are all rational limits. So it's a limit of a rational function. And the limit point is a real number. We're going to later do some where the limit point is not a real number, but for now, these are real numbers. So I'm going to try and, there's a sort of standard technique for doing those that you're going to need to know. And if we sort of break down the steps of what we did as for a limit of a rational expression in number 18, all right, what we did was we rewrote, the first thing we did was rewrite the expression so that in order to be able to factor it. So we rewrote it in a way that we could factor it. Then we factored it. Then we canceled the matching factor, which we usually call simplifying. And then we substituted, and that gave us the limit. So those are the steps for limit of a rational expression. Rewrite, factor, simplify, substitute. All right? So I wrote that out again, don't worry. For the rational limit at a real number, because later they're not going to be real numbers. We're never going to have complex numbers in calculus, by the way. We're going to have real numbers, and we're going to have plus and minus infinity. Some people call that the extended real number set. All right, so here are the steps. Rewrite, factor, simplify, substitute. The rewrite is an optional step. You might not have to. So for example, in number 20, here's number 20 from page 66. Page 66, number 20. Limit as t approaches 2, t squared minus 3t plus 2 over t squared minus 4. So I can factor that already. I don't need to rewrite it. So I can just factor it. So let's just do that. So limit as t approaches 2. My numerator, it looks like it's t minus 1, t minus 2. Denominator is t plus 2, t minus 2. So you really need to be able to look at these and get these factorings instantly. If you can't, or you don't know how that's happening, send me an email and let me know. But by the way, just an indicator, if you can't look at this and just get that immediately, you might need to reconsider whether you should be in BC Calculus. But, give me an email first and we'll talk about it. All right, but I'm assuming everyone can just do that without any trouble. That is the factor step. We just factored. You keep the limit on. Actually, maybe let me add this to my steps. Limit, 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 no limit, all right? In terms of when you're writing the limit statement. Once you do the substitution, you stop writing the limit statement. All right, so this is equal to limit as t approaches 2. You have to write every step. T minus 1 over t plus 2. All right, that's my simplify step because what I did was cancel the matching factors top and bottom. And then that equals, so now I'm ready to substitute. So I just plug in the 2. So I'm going to put 2 minus 1 over 2 plus 2. Could I right away write that it's 1/4? Yeah, I could. But isn't it nice that I showed where that 1/4 came from? I showed that I'm substituting that 2 in. So that is the substitute step. So also, when I do that substitute step, I'm evaluating the limit. So since I'm evaluating the limit, it's not a limit anymore. So where is the limit statement? It's at the beginning, it's in every step until you simplify, and then that limit statement is gone. Okay, limit, 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 no limit. Limit, 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 no limit. All right, now if you look in your book, since the book posted online is actually a teacher's edition, it has the answer right in it. So it tells you right away that it's 1/4. Okay, but you can't just write 1/4. All right, you can't just write number 20 as 1/4. You have to show me the rewrite if there is one, the factoring, the simplification. You have to show that you're writing the limit statement correctly each time, because when you do your free response questions on my test or on the AP exam, I'm going to be looking at what you wrote, and I need to be able to read it. And like one of the points on one of the questions is, did you put the limit statements in the correct places consistently? All right, so that's number 20. I'm gonna do number 22 next. It's a little bit trickier, but if you want to try and give it a shot before I start, you're welcome to do so. I'll put it in the next video.